Hi. So you have seen the properties of graph. What is a graph? What are the different properties of it? Now let's see how you can traverse the graph. How many types of graph traversals are present and their implementation in Java. So before that, let me tell you a difference between tree and graph. Okay, there is a difference between tree and graph. Tree is a special form of graph. So this is an important point. The point is tree is a special form of graph. That is, tree is nothing but a graph, but it is a minimally connected graph and having only one edge between any node. So in tree, as we all know, there is only one edge between any number of nodes. There is only one edge. These are the edges, and there is only one edge between any number of nodes in trees. Correct? On the other hand, in graph, there can be more than one path. That is, graph can have unilateral or bidirectional edges, unidirectional or bidirectional edges between them. Okay, you have seen the examples. Next, there are no loops in trees. So we have seen so many trees till now. There are no loops in trees. But in graph, there we can have loops. In trees, there is exactly one root node and every child have only one parent. There is exactly one root and every child has exactly one parent. We have seen this. In graph, there is no concept of the root. There is no concept of the root where we will begin. There is no such concept in graph. Next point is trees are connected acyclic graphs. So there is no cycle in trees. As we have seen, there is no loops in trees and they are connected through and through. They are connected through and through. That is, trees are just a single component. They are connected. Okay, you can reach every node with the help of root. From root, you can reach each and every node. But graph, they can be disconnected. For example, this is one graph and this is another graph. Okay, so these two is a single graph, but they are two disconnected components. There are two disconnected components, but this is also a graph. Okay, so graphs can be cyclic or acyclic in nature, and trees are connected and graphs can be disconnected also. There can be two connected components of graphs. Okay, this is a tree and this is a graph. Now let's revise what we have just did just now. There is only one edge between any node. As you can see, there is only one edge between two nodes. There is only one edge between two nodes. But in graph, there can be more than one path. There can be more than one path. For example, 10 to 15 can be reached by 10, 30, 15 also. Okay, if I want to reach 10 to 15, there is a path of 10 to 15. There is also a path 10, 30, 15. There is also a path 10, 30, 300, 5, 15. Correct? So in trees, if you want to reach to 15, we can only reach by 200, 20 and 15. There is only one path, but here there are multiple paths. Okay, so the next difference is there is exactly one root, but here there is no root. We can begin our traversal from anywhere. Okay, from any node. Trees are acyclic. As you can see, there is no cycle, and here there is a cycle. See, 10, 30, 15 is a cycle, but 10, 30, 300, 5, 15, 10 again, this is a cycle. But here there is no cycle. Okay, as you can see here, this is nothing but a cycle. Okay, so here also this is a cycle. Fine, but in trees there are no cycles. These are some differences between trees and graphs, but the most important point is trees are a subset of graphs. Okay, trees are special graphs. Trees are special graphs. So whatever algorithms we are using in graph or traversals, we can use them on trees also, and we are using them on trees. Fine, I will just explain you how. So let's see graph traversals. So there are two important points in graph traversals. Fine, now you know what are trees, now you know what are graphs, now you know the differences of trees and graphs. Correct? Now you can think that, yeah, this is a tree, this is a graph. Okay, why this is a tree, why this is a graph, you know the differences. This is acyclic in nature and everything. Fine, so graph traversals are divided into two types based on these two things. What are two things? Visiting a node and exploring a node. Okay, visiting a node and exploring a node. Fine, so let's see what is visiting a node means and what is exploring a node means. So I will first explain using a tree graph. Okay, this is a graph in a form of tree. So first I will explain using this, both the traversals. Fine, after that I will be taking a graph with loops inside of it, and I will explain these two traversals. First, let me explain you what is a visiting a node and exploring a node means. Okay, so for example, this is my visiting array. Fine, visiting array, and this is my exploring array. Fine, this is a visiting array and exploring array. If I visit 200, then I will visit 200 and I will add it into the visiting array. Okay, then I will visit 50, for example, and I visit 20. Once in the visiting array, all the neighboring elements of 200 are also there. Once in the visiting array, all the neighboring elements or the adjacent elements of my 200 node are also present, at that time it is said that 200 is now explored. At that time it is said that 200 is now explored. For example, for 50, if I have 5 and 30 inside my visiting array, then since for 50, 200, 5 and 30, 200, 5 and 30, all the three nodes are inside my visiting array, so 50 is said to be explored. 50 is said to be explored. Fine. 20 is just visited. It is not explored yet. When it will be explored? It will be explored when 15 and 10 both are inside my visiting array. Both are inside my visiting array. That means all the neighbors of 20, that is 15, 10 and 200 I have visited all the neighbors of 20, that is 15, 10 and 200. At that time I can say that 20 is now visited. 20 is now visited. Sorry, 20 is now explored. Fine. So what is the difference between visiting and exploring? When all the neighbors of a node is visited, then at that time the node is explored. Okay. Now let me tell you the difference how this visiting and exploring is done in two ways. First one is breadth first search and the second one is depth first search. Now according to the visiting and exploring, there is a difference between breadth first search and depth first search. Okay. So in case of trees, breadth first search is nothing but like level order. Breadth first search is nothing but like level order. First we will start from here, then we will complete this level, and then we will complete the last level. Okay. So first we will start with our node 200. Red color means that, just remember this, red color means that the node is just visited. Okay. Node is just visited. And the yellow color will mean the node is explored. Fine. So I am adding 200. Now in breadth first search, in a visited array, just add all the neighbors of 200 also. In breadth first search, you have to add all the neighbors. So add 50 and 20 also. Now since 50 and 20 are added into the visiting array, at that time I can say that 200 is explored. Then after that, choose 50 or choose 20. It is your choice, whichever you want to choose. If I choose 50 and add all the neighboring elements of 50 in my visiting array, that are 5, 30, 200 is already present. So 5 and 30 are also added. Since 5 and 30 are also added, I can say that 50 become my explored node. 50 become my explored node. Therefore, the color is yellow. Okay. Now I have visited 20, 35. I have explored 50 and 200. Fine. So for example, now I am taking 20. So 20 is just visited. When it will be explored? When 15 and 10 are added inside my array, at that time it will be explored. So 20 now is explored. Then the next step is there any neighboring element of 5? There is a 50. 50 is already explored, so there is no new neighboring element of 5, so we cannot add anything inside my visiting array. That means 50 is explored, 5 is explored, 30 is also explored because it is a leaf node, 15 is also explored, 10 is also explored. Fine. This is how we are exploring the nodes in breadth first search. As you can see, first 200 is printed, so visiting array means we are printing it. The 200 is printed, then 50 is printed, then 20 is printed. So we are going level by level. First this is printed, then this level elements are printed, 50 and 20, then the last level elements are printed, 5, 30, 15 and 10. This happens in breadth first search. Now what is the difference between breadth first search and depth first search is, in breadth first search we go level by level, but in depth first search we go from the top to the bottom first. Okay, let's see that. So in depth first search, let's say we start from 200. Now after 200 is just visited till now, it is not explored, so we can go either to the 50 side or we can go either to 20 side. Sorry. So for example, we go to the 50 side first. Okay, so we visit 50. So I'm printing 200 is printed, 50 is printed, so I am visiting 50 now. So in breadth first search we would visit 50 and 20 both. Okay, all the neighbors of my node. But now what we have to do, we have to choose a single neighbor. So we have choose 50. After that, 50 also have two choice. Either it can go to the 5 or it can go to 30. Okay, so for example we are taking 5, so it visits 5. So 200, 50 and 5 are printed. Next what we have to do is there any neighbor of 5? No, there are no neighbors of 5 except 50, which is already visited. So 5 becomes explored. Fine. After that it will go back to 50. It will go back to 50 and see if there are any other nodes of 50, and see if there is any other nodes of 50, any other neighbors of 50. So yes, 30 is another neighbor of 50, so it will add 30. So it will add 30 to the visited array. Fine. So now we have printed 20, 50, 5 and 30. correct? Is there any other node or any other neighbor of 30? No. So 30 is nothing but explode. So again it will go back to 50, and again it will see, is there any other array of 50 left, any other neighbor of 50 left? So no other neighbor of 50 is left, because 50 neighbor are 5, 30 and 200, and both all are visited. Okay, so it is explode. So it is completely explode. Now it goes back to 200, and when it goes back to 200, it will see from 200 whether there are any other neighbors left to be visited. Yes, 20 is left to be visited. So it will now add 20 into my visited array. That means it will print it. Okay, now 20 will see either it can go to the 15 side or 19 side. For example, it goes to the 15 side, so 50 is now visited. Now you know what we have to do. Okay, now the same things happened in this side also. You have to do the same thing here also. Now just think what we will have to do. Is there any neighbor of 15 which is not yet visited? Is there any neighbor of 15 which is not yet visited? No, there is no neighbor of 15. So means 15 is explode, right? So means 50 is completely explode. So we can add 15 to the explode array. Fine. Then where we will go? Just think, I have done this one, therefore I am asking you. So now where we will go? We will go again back to 20. And what we will do when we go back to 20? Just think what we will do when we go back to 20. What we will do is we will check. What we will check? We will check that the neighbors of 20 are all visited or not. So 15 is explode, that means it is visited. 200 is visited, okay, because the red color, yellow color is for explode, and the green color means it is not visited. It is not visited yet. So we will add 10 to the visited array and we will print it. Fine. So 10 is now visited as well. So is 10 explode? How we will check if 10 is explode or not? Are all the neighbors of 10 visited? Just say 10 neighbor is 20. Is it visited? Yes, it is visited. So 10 is completely explode, and we can add 10 to the explode array. Then what we have to do? Check for 20. Come back and check for 20. When we check for 20, is 20 visited? Is 20 explode completely? Just check, is 20 explode? So all the neighbors of 20, are they visited? 15 is visited, 10 is visited, 1200 is also visited. So yes, 20 is completely explode. Now think what will happen. Where we will go? Now we will go to 200. Now we will go to 200 and see, are all the neighbors of 200 visited or not? So who are the neighbors of 200? Just think, who are the neighbors of 200? So the neighbors of 200 are 50 and 20, correct? Are they visited? Yes, and they are explode. Okay, but they are visited now. So since they are visited, we can tell that 200 is explode completely. 200 is explode completely. So this was how depth first search explores it. Fine. But what depth first search does, it goes from top to down. It goes from top to down. What breadth first search does, it goes from level by level. It goes level by level. Fine. Now the two similarities between this depth first search, breadth first search with tree is that breadth first search is similar to level order traversal, correct? And depth first search is nothing but we are printing pre-order. We are printing pre-order. In case of trees, breadth first search is level order traversal, and depth first search is nothing but pre-order. As you can see, if you write a pre-order of this tree, it is nothing but 255, 30, 20, 15 and 10. Am I correct? So breadth first search, just make a point, breadth first search is similar to level order traversal in tree, and depth first search is similar to pre-order traversal. Level order traversal of tree is actually inspired by breadth first search only. It is inspired by breadth first search only. And I have explained you that tree is nothing but a special graph. Tree is nothing but a special graph. Now you know how visiting a node and exploring a node is done in depth first search and breadth first search. Okay, while using tree as a graph. Fine. Now what we will see is, we will see how it is actually done using in a loop graph. Okay, in a graph which is containing a loop and which is not like a tree. Okay, it was easy to understand in a tree, depth first search and breadth first search, but in a graph, let's understand how it will be done. Fine. So it is breadth first search, and in a graph which contains many nodes. Fine. And it is not compulsory that 50 here is a root. I am starting my breadth first search from 50, but it is not compulsory that you also begin the breadth first search from 50. You can begin from 5 also. You can begin from 200 also, 300 also, or any point, any node. From this you can begin your breadth first search. I am beginning it for 50, therefore I have colored it red. Fine. So now what we will begin is breadth first search. So here 50 is nothing but visited, but it is not a visiting queue. It is not visiting, it is nothing but a queue. Breadth first search uses queue. Breadth first search uses queue. Now I am going inside. First I was explaining only what is a visited and exploring a node means, but now I am going inside, and this is what we will be printing. This is what we'll be printing. Okay, this is a queue. This is what we'll be printing. In this array printing will come, in this array queue elements will come. Okay, and the color will tell you whether it is visited or not. So the red color is for visited, and if a node becomes yellow, that means it becomes explored. So take care of that. So color will tell you whether a node is visited or not, or explored or not, and this is a queue, and this is for printing. Fine. So we are printing nothing right now. We are printing nothing right now, but we have enqueue50. When we have enqueued 50. So first operation that you have to perform is, from wherever node you are starting, enqueue that node. First operation is enqueue that node. Fine. So first operation 50, so we enqueue 50. Second operation is dequeue that node and print it. Dequeue that node and print it. So we will print 50. We will print 50. Correct? And at the same time, what you have to do, you have to add all the neighboring elements. In that first search, what we have to do, we have to add the neighboring elements, all of them. In that first search, one by one we do, but here all of the neighboring elements should be added. Fine. So what is the third step? Add the neighboring elements, add the adjacent or the neighboring elements, whatever you want to call them. Okay, adjacent or neighboring elements. Fine. So these are the only three steps. First enqueue, dequeue and print, and add the adjacent neighboring elements, and done. This is best first search. Fine. So let's just do it. So 50 is now in the queue. We will dequeue 50 and we will print 50. Okay, dequeue 50 and print 50, and after that we will add the adjacent nodes of 50 in the queue. We will enqueue them. So let's begin. Yes, we have done it. 50 is now what? Explored. Why? All the nodes of the 50 are visited. As you can see, they are of red color. All the nodes of 50 are visited, and we have enqueued all the neighbors of 50 as well. You can enqueue 10 first, or you can enqueue 200 first. It doesn't matter. Fine. I am enqueuing 200 first, then I am enqueuing 10 first. We have printed 50. Now what is the next step? Just repeat those steps. What was the first step? Enqueue. We have done that. Okay. What is the second step? Dequeue and print. Dequeue and print. So dequeue 200, because in queue whatever comes first also dequeues first. Whatever is enqueuing first will be dequeues first. That is first in first out order, because this is a queue. So 200 will be dequeued, it will be printed, and its neighbors will be added. What are the neighbor of 200? 20. The neighbors which are not yet visited will be added. The neighbors which are not yet visited. This is the important point. Okay, 50 is visited and explored, but this is not visited. This is of green color, correct? So 20 is added. So this is done. So what we have done here is 200 is now dequeued, it is printed, and its neighbor is added. Now you know what are the steps. What the first step? Dequeue 10, print 10, add its neighbor. Add its neighbor. Who are the neighbors? 50, 15 and 30. So 50 is actually visited, so 15 and 30 will be added. 15 and 30 will be added. Fine? Clear? This much is clear? So let's do this. So 10 is now dequeued, it is printed, and 50 and 30 are added. Now for 20, is there any neighbor of 20 which is not yet visited? No, there is no neighbor of 20 which is not yet visited. So what we have to do, we have to simply dequeue and print it. Dequeue and print it. Done. Then come to 15. So is there any neighbor of 15 which is not yet dequeued, which is not yet printed, which is not yet visited actually? So yes, there is a neighbor 5 which is not yet visited, which is not yet visited. So what we have to do, we have to add 5. We have to dequeue 15, we will dequeue 15, we will print 15, and we will add 5. Okay, see, done. It's very simple. Now tell me the next step. Which node we will access? We will access 30. We will access 30. Now tell me what will happen. What is the first step? First we will dequeue it. Fine. What is the means? We have enqueued it. Now the step is we will dequeue it. We will print it. Okay, so I'm printing it. We are dequeuing it, we are printing it. And tell me the last step. The last step is add all the elements of, add all the neighbors of 30 which are not yet visited. So which are those elements? There is just 30 here, there is just 300 here, sorry. So 300 will be added. So see, 300 is added. Okay, now I think all the elements now are visited. Okay, because there is only these two elements which are visited, and all are explored, so means they are visited. So only 5 and 13 are left, 300 are left. So 5 will be printed, and now 300 will be printed. There is no other neighbor left that is not visited yet. So at the end, all the nodes will be explored, all the nodes will be visited. Fine. There is a difference between visiting and exploring, which I explained you before. Okay, so this is depth first search. So in depth first search, what we do is, first a node is taken and its all the neighbors are printed. Okay, so for 50 and all the neighbors of these nodes are printed, 210. Now the order can be different. For example, If I take 50, then I print 10, then I print 200. Fine. So after that, the 10 neighbors will be printed. For example, we can have 15 and 30. We can have 15 and 30. After that, 200 neighbor will be printed, that is 20. After that, 15 neighbor will be printed, that is 5. After that, 30 neighbor will be printed, that is 300. So this will be my array. This will be my printing sequence. Now you can have n number of printing sequence. There are many numbers of printing sequence, many permutations of this graph, how you will do breadth first search. Okay, there is no one correct answer. You can have many. So what you have to do is write two of them. Just write one or two of them more. There are two of these breadth first searches. Okay, there are these two breadth first traversals, but there can be more. Fine. So just search for them. Search for them. Just do the same process again and find search for them. So I have gone to 50. I have gone to 10. Don't go to 15. Go to 30 first. Okay, then there will be a new breadth first search. Fine. Just printing sequence will change. So find more printing sequences. So this was breadth first search. Fine. We will use a queue in breadth first search. We will use a queue in breadth first search. Okay. Now we will see depth first search. Okay. Now we will see depth first search. And depth first search is done mainly using recursion. It is done using recursion. So in recursion, whenever recursion comes, text comes automatically. So we will use recursion in depth first search. So this is depth first search. Now we will start with we will start with 50 only. So we'll start with 50. Fine. We are not printing it, not now. Okay, we will start with 50. Since we have visited 50, just print it. Since we have visited 50, just print it. So let's see. Yes, we have printed it. Since we have visited 50, just print it. Now what you have to do, you have to either add 200 or 10. For the neighbors of 50 are either 200, fine, or the neighbor of 50 is 10, okay, which are directly connected to it. So you can add either 200 or 10. It is your choice. Okay, depending on your choice, your printing sequence will change. Now I am adding 200 to it. I am adding 200 to it. So 200 is printed and it is visited. After 200, what you have to do is now what you have to do is save 200. Okay, 200 neighbor is only 20. So print 20. Fine. Is there anything of 20 left? No, 20 neighbors are printed. So 20 will become explode. 200 will become explode because all the neighbors of 200 are visited. Fine. After that, it will go to 50. After that, it will come back to 50 and it will check, are all your neighbors visited? So 50 will say no, my 10 is remaining. So it will now add 10. It will now add 10. Now 10 will check, are my all neighbors visited? No, the answer is no, because 15 and 30 are still left. Correct? Yes, 15 and 30 are still left. Now tell me what will happen. Where we should go? We should go to 15 or we should go to 30? It doesn't matter. You go to 15 or 30, the whole graph will be traversed. Fine. So go to 15. So if we go to 15, then 15 will be visited. 15 will be visited. Now go to 15. 30. We should go to 30 or we should go to 5. Or we can go anywhere. We can go actually anywhere. So I go to 5. Fine. So 5 become visited. Now check for 5. We can go to 300. So we went to 300 and 300 can only now go to 30 because all the neighbors of 300 except 30 are now visited. So it will print me a 30. Okay, at 30 now it will check. Now we are here and 30 now it will check whether all my neighbors are visited or not. Yes, all its neighbors are visited. It has 4 neighbors and all are visited. So it will become explode. Okay, now it will go back to 300. It will go back to 300 and 300 will check, are all my neighbors visited? So yes, all its neighbors are visited. So it will explode. It will be explode. So now 30 will go back to 5. Fine. 5 will check, are all my neighbors visited? Yes. So it will be added to explode. Then 5 will go back to 15. It is the same path we have just came. So 5 will go back to 15 and 15 will check, are my all neighbors visited? Yes. So I will be explode. 15 will go back to 10 and it will check, are its all neighbors visited? 10's all neighbors are yes, they are visited. So it will be explode. So 10 will go back to 50 again. And similarly here, what it will do, it will check whether all my neighbors are visited. Yes. So it is done. So this was depth first search. Okay. In depth first search, what is the difference? I think you clearly know what is the difference of BFS and DFS now. I think it is pretty much understood what is the difference between BFS and DFS. So in BFS, what we are doing is we are going to a node and we are taking all its neighbors. We are taking all its neighbors at once. Okay, but in DFS what we are doing is we are going to a node and we are taking only one of its neighbor. Okay, when this neighbor exploration is complete, then we go to previous one, that is the previous node, and we check whether any other node is left or not for exploration, for visiting purpose. Okay, So this is the difference between BFS and DFS. Now what we will do is we will code them. We will code BFS in Java and we will code DFS in Java, and we can get many number of different sequences. Fine. It depends on whether you choose which node first to go. The printing sequence will change. You can have many different printing sequence for DFS and many different printing sequence for BFS also. Fine. So this is the difference between BFS and DFS. Now let's do some coding. Okay, the explanation part is over. Now the coding part will begin.